Hello, chemistry students. This is Mr. Feynman again, and I understand yesterday's video didn't work. Thank you to the two people who pointed that out to me. I tried a lot of things and I'm not sure what went wrong. I've done the same thing with larger files and it's worked. Google Drive wasn't able to download it. It said check back later. I posted it to YouTube, which I've used in the past with no problem, and I just got the circle, 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 and it wouldn't show. So thank you to the two people who let me know that there were problems. I really, really appreciate that. You get board points. Well done. Everybody else, you didn't get a chance to watch the video. If you're able to do the assignment and got the great feedback, fantastic. But if not, I think many of us don't understand how to do dimensional analysis, so a little review is in order. So here we go. Remember dimensional analysis? It's a great, great, great way to convert units by multiplying fractions. Some people like to convert units by multiplying, but then sometimes you divide. If we do dimensional analysis, it always works as long as we follow the rules. What are those rules? First rule, before you start, you have to know what information are you given and what information are you looking for. You have to know that. If you don't and you're guessing, you're going to make mistakes. Once you know what's given, start with the given, include units, but you divide it by 1. Don't put units on the 1. Okay, it's just to make it look like a fraction. Then we're going to multiply it by another fraction. That fraction, there's two rules it has to follow. The goal units are in the numerator, but the given units are in the denominator. That's really important because those units are going to cancel. Before they were in the numerator, now they're in the denominator. Those cancel. The goal units don't cancel. That's what we're looking for. Second rule is you put the numbers in so that the overall numerator and the overall denominator of your second fraction have to equal each other. Okay, let's see this in use. Here's a problem that was in the assignment a day or two ago. All right, I'm giving you 1.63 moles of gold. That's the given. The question is, how many atoms is that? So, given over 1. Here's my gallery. I'll pull things out of the gallery. Given over 1. Okay? Um, for the lesson we've had, you didn't need to know that it was gold. That will change as we get to things that are a little bit different. So I always make it a habit, write the number and the unit and the chemical formula. All right, given over 1. What do? We multiply it by a fraction. So multiplied by a fraction. I'll just make a blank fraction first. Then, what goes in that fraction? I'm going to put my units. I want my goal units to cancel. So my goal unit goes down there. I want my given unit to be there. Okay, I need numbers in here too. How many atoms are the same as how many moles? Avogadro's number tells us how many atoms are in a mole. So I put that up in my numerator and 1 mole in the denominator. Notice that I can cancel out moles. And I'm going to do that. Cancel the moles there. Cancel the moles there, which is great. But notice that the atoms are going to survive, are still there. Okay, so that's what we have, and then equals, and then I do the math, and in this case I just multiply straight across. My denominator is 1, so I don't even have to worry about that. Okay, that's how you solve that problem. Here's a different problem. This was also in that assignment. Different given. I'm telling you how many atoms there are. I'm telling you how many atoms there are, and the question is how many moles is that? So this time I'm going to set it up the same way, but the effect is going to be different. I start with my given over 1, just like before. Given over 1. And just like before, I multiply it by a fraction. Whoops, a fraction. Okay, but this time my given unit was atoms, so I put atoms in the denominator. My goal unit is moles, right? It says how many moles. So my goal unit is moles, so I put that up there. Where do I put my numbers? Avogadro's number tells me how many atoms are in 1 mole. So Avogadro's number goes down there. 1 mole goes at the top there. That's a different setup from the previous problem, right? Previous problem, we put atoms in the numerator. Why? Because moles was the given. Avogadro's number of atoms always goes with 1 mole. New problem, Avogadro's number of atoms goes with 1 mole. They're in different places, but the number and the unit has to match. Okay, now I'm ready to do my math. Equals, again, the units of this time atoms are going to cancel, because that was my given. That's what I don't want. Moles is what I'm left with. This time the math, I'm going to just write an extra step. I'm going to multiply across my numerators, multiply across my denominators. I'm going to plug this into the calculator, and I'll get a decimal. It'll be a very, very small number. It's 6.6 something times 10 to the negative 9, if you do it right. Be careful with your scientific notation. Okay? You should get 6 point something times 10 to the negative 9 in your calculator. If you did that, you did it right. All right. If you saw this and didn't understand it, please, please, please be in touch. If you did the work and you didn't get the right answer, please send me a copy of the work that you wrote down so I can see what you're doing. If you're doing something wrong, I want to help you, but I can't help you unless you help me help you. So that is the plan. I think we can do this. I know we can do this. So go, Cats.